Hello guys, welcome back to Maison African Motives, still on Engineering Science N3. In this moment, we are going to be focusing on forces. That is revision that we are having in this platform from November 2022 question paper. So we were given the first part to list two conditions of equilibrium of a system of forces. Okay, so what are the conditions? All right, so you have got a list of conditions that you can choose from. The vector forces form a closed triangle. So for the first part, the algebraic sum of the components of forces in any size is equal to 0 in any direction, okay, is equal to 0. And the algebraic sum of moments of the forces about any point, again, it's equivalent to 0. Then the line of action of the forces meet at a point, and also the forces of vectors are coplanar. So you can choose any two from these ones that we are given. So that is what we had from the first question, the conditions that we have for equilibrium of a system of forces. Okay, on 3.1, we are given that various options are given as possible answers from question 3.2. Okay, choose the answer that and write only the letter that is A to D next to the given number that is 3.2 in the question. Okay, 3.2, two forces acting on a point, you've got a resultant of 0 Newton. Okay, so if two forces are acting at a point, then the resultant is a 0 Newton. What is it that we have? Okay, how are they related? The first one, they've got equal magnitude and direction. B, they act perpendicular to each other. C, you have equal magnitude, but but opposite directions act in the same direction. Okay, so for us to have a 0 Newton, guys, it's on a condition that we have got a force here acting maybe to the left, that would be -5 Newton, to the right with also +5 Newton. So if you combine these two, the one that is going to the positive and the one that is going to the negative, you're going to obtain a resultant of 0 Newton. So the best answer that we are given there is a C, where we have got equal magnitude but opposite directions. That's where we can obtain a resultant of 0 Newton. Okay, from your engineering science N2, you have this part as the first part that you work with. So please just grasp that idea from there. All right, on 3.2, we are now given the diagram below shows four coplanar forces acting on a point. If this system of forces is in equilibrium, take note, that's the horizontal component will be equal to 0. The vertical component will be equal to 0. All right, we are given determine the following. Okay, so what is it that we are supposed to determine? Let's check on the other part of the question what we are given to determine. 3.31, that's the sum of the horizontal components in terms of A and B. What is the sum of the horizontal components in terms of A and B? Okay, so this is what you're going to have, guys. From our diagram, this is what you need to note. I explained that you can change these directions so that they suit the best way in your consideration of answering these questions, okay? Yes, we must know that if there is a force that is acting, like we are pointing to the point of contact here. If you are going in this direction, it means that is going to be a negative. All right. So to avoid the use of negative and the introduction of negative, this and that, always take all your forces from the point of contact outwards, okay? All your forces must be taken outward. That can actually assist you or save you time because there is no introduction of negative part that you need. You need to take your forces as they are. All right. So that is the best part that you can do. So in this case, I can just have a re-sketch. Okay, I can just re-sketch this so that it can help me to answer this question. So take note here. The force, okay, let's start with A. our A here, it's pointing inside, which means it has to proceed straight as it is to the other side. Now it's on the positive. That is what it means actually. Okay, so the A that we see is going to be taken that way. So you can just have a smaller diagram, just a presentation, guys, so that you can understand me. So this is our new A. From where it was here, our A was pointing here. So now we take it from that point straight. All right. So we now have our A from the point of contact, not at the point of contact, okay? The same thing, if we are to check here, the A is a vertical line, that's a horizontal line, then we have given the 80 Newton, which is a vertical line. So these two, they're actually perpendicular to each other. All right, so we are given, let's check back. These two, they'll be perpendicular to each other. And that means B, if we are to take this 80 Newton, it's pointing inside. So if you had to take it like the way that I was presenting, it's supposed to correspond straight as it is to the top. All right, so this is going to be 80 straight to the top. It was taken from this 80 here. So the one that we took it from, I'm just going to indicate with dotted lines. That is where we took our 80 from. So it continues as it is straight upwards, okay? That's 80 Newtons straight upwards like that. All right. So now it's pointing out from the point of contact, not the way that it was doing. It was pointing inside. All right. So this is our 80 Newtons there on top. All right. Let's see what is happening here on 100 Newton. There's nothing. It's just 100 as it is. So it's pointing outside. So it's not going to change anything. So we are going to have our 100 Newton back to where it was. Okay, let's just try to resketch this. Okay, so this is going to be 100 Newton as it is in that direction, and the angle was 50 degrees in between. Okay, so here we are given 50 degrees. All right, so this angle at this point between the horizontal line and this is 50 degrees. This is our horizontal line. Okay. So we are left with B, okay? So B is also pointing inside. So it has to continue to that part as it is straight, okay? So we are going to see our B taken from where it was. Our B was like this from the original diagram. Our B was like this. All right, now it's at this point, we take it straight as it is, okay? So this is where we are going to have our B. It's pointing out now. But what is the angle that is going to affect? Because the angle has to be between the horizontal line and the force. If the force is like this is the angle that you need. If the force is like this is the angle that you need. If the force is like this is the angle. It's supposed to be between the force and the horizontal line. So we have to calculate or to find this angle here between the force and the horizontal line. That is this angle here. So how are we going to have this angle? Okay, let's get back to the diagram here. This is our diagram. We're going to take our answer from here. This is a horizontal line, like I said. So if we continue with this horizontal line like this, it's a straight line. So we've got 50, we have got 70 degrees, and we know that angles on a straight line, they add up to 180 degrees. Okay, so what are we going to do now to calculate this angle? All right, if we add these two, that's 50 plus 70, that's 120 degrees. So from 180, this is going to be 60 degrees. All right, so that means in between here, this force, okay, in between B, there's a 60 degrees. So this was our B from this point. Take note, that is where we took our B from. So the angle before that we had at this point here was 60 degrees. And this angle and the angle that we need, that we indicated for B, they are actually the same. From our mathematics. We know that these are called vertically opposite angles. So that means the angle that we actually need here is 60 degrees. Okay, the rest of the angles that we have, they are not of matter. So this 60, this doesn't matter, or you can just even leave it like that. Okay, so let's just leave it like that, but it does not matter at all. Okay, what about the 80 Newton? Remember, the 80 was taken on a vertical line. So when a vertical line meets a horizontal line, they meet at 90 degrees. So that means 80 Newton is at 90 degrees from A, like from the horizontal line like that. So this is the new diagram that can actually help you to calculate whatever that you're given from this diagram. Okay, so you're going to use diagram 2. Okay, so in the first diagram, then we rechanged into this diagram. Okay, so the question was asking us to calculate or to write the sum, take note, the sum of the horizontal components in terms of A and B. Okay, so that's it. So why am I doing this? It's going to help us to answer all the other questions. Don't mind that it is 1 mark. So why are we wasting time doing this? Don't mind about that. Yes, you can write, actually in another video, we are going to work this same diagram, but in another way, which is the easiest, but it has a lot of errors, that method. And that's why I avoid that way. Okay, anyways, let us see what we're going to have. Remember, we need the horizontal components. So we are going to have in this way. All right, let's see. So our horizontal components, remember, they are written in terms of cos of theta. Okay, so in this case, we are representing the horizontal. Okay, so that means our horizontal component is going to be, so this was 3.31. So let's start at A. A in this case is a horizontal line. It's a straight horizontal. So we're going to take that as it is. It's a positive. Okay, the angle there was supposed to be 0 degrees. So if you say A times cos 0, we know that cos 0 is equal to 1. So it is going to remain as A, but it was supposed to be cos 0. We are at 0 degrees here. Okay, we move on to 80. 80, it's a straight vertical. So there's nothing that you're going to have because it was supposed to be 80 cos 90 degrees, like, but cos 90, guys, that's a 0. Or you can just write it, okay? So you've got plus 80 cos of 90 degrees, which is a 0 there. Okay, then we move on to the other side that we have. If we are to check from this side that we have, the horizontal is now on the negative side. So whatever that you're going to take, it is supposed to carry a negative. Okay, we are now on the negative side. So that means we are going to have 100 with a negative. So that's minus 100 cos of the angle between the force and the horizontal line. The force between the angle between the force and the horizontal line is 50 degrees. So that's cos 50 degrees. And we move on to B. B in this case is also affected on the horizontal, but it's on the negative. So that's negative B cos of the angle between B, which is the force, and the horizontal line. The angle between is 60 degrees. So that's cos 60 degrees. Okay, so that is what you're going to have. But like I said before, guys, cos 90, that's a 0. So which means you can write this in simplified that as A minus 100 cos of 50 degrees minus B cos of 60 degrees. So that is the horizontal component that you're going to have. You can simplify if you want, but just leave it like that, guys. Okay, on 3.32, we are now given to calculate this time the vertical. All right, so let's check properly our question. That's the vertical component in terms of B. Take note, they know that your answer is going to be in terms of B. So let's see, is it going to be in terms of B alone, or we are going to find A there? Okay, so in this case, for the vertical component, we know these ones, they affect sine of theta. So A, remember we said A is a straight horizontal. So there is no way we can have this as a vertical. It is going to be like A sine 0 like that. And A sine 0, that's a 0. So you're going to have nothing there. We move on to 80. 80, it's a straight vertical. It's actually a vertical component that we have, and it's going up, which is a positive. So we are going to have this as a positive 80. So that's 80. All right. We are now on the other side, which is the left side. But the advantage that we have, we are dealing with the vertical. Okay. So if you are to check here, this is the vertical. It's on the positive. It's up there. So which means everything that is up, it's a positive. So our answer is going to remain with a positive, but having sine. So it's 100. So it's going to be plus 100 sine of the angle between the force and the horizontal line, which is 50 degrees. Okay. On the force B, we can see it's now down here. that is below the horizontal line. So anything that is below in terms of this line, that's our vertical. If you were to check below here, our vertical is in the negative. So this one is going to give us a negative. So that's negative 60, negative B, sorry. So that's negative B sine of 60 degrees. All right. So all this part that we have, it gives us the whole of the vertical component. All right, so that was 3.32. We move on to the other part of the question, which is 3.33, the magnitude of A and B. All right, remember we are told that these two are in equilibrium. So if they are in equilibrium, like what we are given here, that these two forces or the forces, the system that we have, it's in what? Equilibrium. That means we can formulate equations in this case to calculate A and B. How are we going to formulate the equations? We know that the horizontal component is supposed to be equal to 0. Okay, so this is 3.33. All right. The horizontal component must be equal. So the whole of this equation is supposed to be equal to 0. That's A minus 100 cos, right? That's 100 cos there. So it's going to be cos 50 degrees minus B cos 60 degrees must be equal to 0. So we've got our first equation in this case. So you can just have this as our first equation. We move on to the second equation. The vertical component also must be equal to 0. So we're going to take the vertical component as it is. That's our vertical component in this case. That's 80 plus 100 sine of 50 degrees minus B sine of what? Of 60 degrees. Okay, so this whole part that we have is equivalent to 0. Okay, so if it is equal to 0, therefore, we can solve for A and B. How can we solve for A and B? If you are to check properly, guys, I want you to see properly here. From our second equation, this is our second equation. If you are to check properly, you are going to see that we only have one unknown, which is B. So we can take advantage of that because there is only one unknown, which is B. So we can calculate B from this part. How are we going to calculate B? We simply have to make B the subject from equation 2. So we're going to remain with 80 plus 100 sine of 50 degrees, which is equivalent. Transpose negative B sine 60 to that side is going to be positive B sine of 60 degrees. So to find B, simply divide by sine 60, simply divide by sine 60 degrees there. So this can actually cancel. So that's the value for B. If you calculate properly, you're going to obtain something like 180.83. All right, Newton. So that's our B there. All right, to find the value for A, now we can just substitute our B into the equation 1, because in equation 1, we've got B and A in this case. So that means we have to substitute, just make A to be the subject there. If you are to make A to be the subject, that's transposing all these to the other side of the equation. This is going to be positive 100 cos 50 degrees. We transpose negative B to this side is going to be positive B cos of 60 degrees. All right, so that's what you're going to have. So A is going to be 100 cos of 50. That's 100 cos 50 degrees plus B. Remember our B is 180, comma, whatever that we have. So it's 180, comma, 83 cos of 60 degrees. So make sure that your calculator is in degrees, guys. Simplify properly here. We are going to have 4.69 Newton, something like that. If you round off to 2 decimal places, that's what you're going to have. So that was question 3.33, where we are given to calculate now the values of A and B from that information that we had. All right, so let's check what we have on the other part of the question. All right, still working from this information or from the diagram that we have. Let's see now what are we asked. Okay, on 3.4, we are now given to find the magnitude of the equilibrium. Okay, remember this is in equilibrium, guys. So actually the resultant in equilibrium, that is going to be a 0 Newton. Okay, that's 3.34. On 3.4, we are now given to study the diagram below. Okay, they are saying you must study this diagram. Okay, answer the questions that follow. Okay, so that's the diagram that we are given. So from the diagram, we are given determine the reaction. Take note, guys. Determine the reactions of supports A and B. Okay, we do want to find the value of A and the value of B. Okay, so what can we do in this case? Okay, I want you to take note, guys. If you are to check here according to these forces, that, to the force of 30 Newton, okay, we have got an isosceles triangle here. Actually, it's an equilateral because remember that angles in a triangle must add up to 180. So 60 plus 60, that's 120. 120 from 180, this is going to give us 60 degrees. All right. Also here, this is 60 degrees. So that's an isosceles, which means we've got equal distance between A and G, between F and B. We have got equal distance, like this is X and this is X. And okay, there is a 30 kilonewton, which is in between these forces. So it's like this, guys. Let me represent this way so that you can understand what I'm trying to say. So it's like this, we've got our beam like this, okay? This is where we've got our A and our B. This is where we have got our A here, and this is where we have got our B, okay? There is an equal distance between the point load that we are given of 30 kilonewton there. That was 30 kilonewton. There is a point load of 30 kilo in between these, but we've got same distance. This is X and this is also X because we are not given the distance. So guys, what does it mean? What does it mean? What does it mean from us? We've got same distance in between. So that means these two forces, if we are to find them, they're actually equal in value. Remember, from our moments or from the forces that we have, the sum of the upward forces but these two forces must be equal. So if we are to write these two forces, let's say this is force M or force whatever that we have, they are equal in value. So which means we are simply dividing 30 kilonewton by 2, which is 15 kilonewton. Okay, so we are going to have A as 30 kilonewton as 15 kilonewton, and here we have got B as also 15 kilonewton. So that's why we've got 2 marks there. They know that this question is just a matter of looking at the question, then just looking at the question, guys, for the answer there. Yes, if you want to apply the moments, it's fine. It's still fine, whereby you're going to say the sum of, if you are, let's say we are focusing with B here, then you take the clockwise moments, which is 15 times the distance. So it's going to be 15 times X plus X. Well, this is X, this is X. Is okay. Do we have anything that is going in the clockwise from B? We do not have. Then we move on to the 30. So 30 back to B is the anti-clockwise. So it's 30 times X, okay, like that. So you can actually, okay, this is 15 and the distance here is 2X, okay? And the other one here, it's 30 back to this point B, which is actually equal to what? Which is going to give us 30 times X. That's 30X there. So if you are to check in this case, we are obtaining 15 times 2, which is 30X is equivalent to 30X. Doesn't make sense at all. 30X and 30X. So it simply tells you that these two are the same in terms of the values. So that's why you simply have to divide. I hope you understand. If not, then we shall try to have it in another way if we are to work with another video again that can actually help us. All right, so that was it, guys. We have A and B in this case, so we can just substitute here. So this is 15 kilonewton and this is 15 kilonewton. All right. So from there, we are now given on 3.42 to determine the magnitude and nature of DE and EG. Okay, so let's see, we've got DE. So this is where we have our DE. I just want you to see here. Okay, so this is no longer important. So we have got our DE from this point here. All right, so this is actually representing the vertical component, okay? So that means we are supposed to work with the vertical component. So DE being a vertical component from this distance that we have here, and also 15 being a vertical component, we can equate these two to find DE. All right, so the vertical components we are actually representing to the forces that are going up and the forces that are going down. So we know that the sum of the upward forces must be equal to the sum of the downward forces. So up, we are representing to the force that is, which is the 15 kilonewton, which is facing up. So that's 15. The one that is facing down is the one that is on top here. So it is going to be facing down, which is DE. So that's DE. But remember, every is supposed to be affected by an angle. If there's an angle like this, so it's DE sine. Remember, guys, always vertical component forces up, they carry what? Sine. So this is DE sine of 60 degrees. So we've got DE sine 60 degrees. All right. So to find DE, we can simply divide by sine 60 both sides. We divide by sine 60 both sides in this case. So this can cancel. So DE is equivalent to 15 divide by sine 60, which is going to be 17. If we divide properly, that is going to be 17,321 and so forth. Okay, so that's kilonewton. Okay, so what is DE representing, guys? DE, that's a strand. Okay, so here we are having DE as a strand. So I hope we understand this, guys. I think we have worked with so many videos for this, and up to now, guys, I think we have an idea there. All right, what is happening to EG? Let's check, where do we have our EG? All right, that's E to G. This is where we have our EG in this way. All right, so for EG, we are going to work with the horizontal component. And every horizontal component, we know that it carries or it obtains, it works with a cos. So we are going to have the cos of theta. So in this case, for the horizontal, we know that we are going to take the forces which are on the right side and the forces which are on the left side. Okay, so the sum of forces which are on the right side, so we can just write here, is equal to the sum of forces which are at the left. That is for the horizontal components. All right, so on the right side, which part do we have on the left side? Which part do we have in this case? Okay, so we've got our DE, okay, this part of DE affected by the angle of theta, okay, which is taken on the left. Then EG in this case being on the right. So this is the horizontal part of EG, which is on the right side. Okay, so we are going to have EG on the right side, which is equal to on the left, we are left with in this case, we are left with the DE, and there's an angle that is affecting the DE now, which is 60 degrees. So to take down this DE to be a horizontal, it has to be affected by what? By cos. So this part is only that it applies also those mathematical calculations, also trigonometry, this and so. Guys, please make sure that you revise also on your trigonometry there. All right, so the theta is the 60 degrees. So let's write as 60 here there. So this is 60 degrees. And our DE, we calculated this DE before. If we had to check, we have got DE here. So that means our EG is going to be DE, which is 17,321 cos of 60 degrees. All right. So we are going to have something like 8,661 kilo Newton, like that. And we know that's a tie. So this is going to be a tie. So like I said, guys, there are so many methods. So you might have been taught another method. Let's know, guys, on the comment section there, so that we can work on that method on another platform or on another video that we are going to have on Science N3. It can actually help others to revise more questions also. Okay, but for now, that's what we had, guys. Working on forces from November 2022 question paper from Maison African Motives till we meet again.